Let's look at two important trig limits using the squeeze theorem. The squeeze theorem says that if a function g of x, drawn here in blue or green in the middle, is squeezed between two other functions, h of x, drawn in blue or dark blue, and f of x, drawn in orange, so that f of x is always, the function values of f of x are always below those of g of x, and the function values of g of x in turquoise is always below those of h of x, then if at a particular point like A, the functions all come together so that the bottom function and the top function are the same, then the function in the middle must have the same limit. This is a natural argument. If f and g squeeze, if f and h squeeze g and f and h come together at a place, then g must be at the same place too. The squeeze theorem is useful in finding a very important limit in trigonometry. Notice that from the geometry of the circle, that if an angle theta measured in radians is close to 0, is in the first quadrant, then theta is between the sine of theta, which is this height in blue in the picture, the y value in blue, and the tangent of theta, which is drawn in orange. And of course, we're measuring things in angles in radians. In general, what we have in this picture is the sine of theta, that vertical measurement, is less than theta, that arc length, is less than tangent of theta, the orange vertical measurement. Then because, as we said a moment ago, sine of theta is less than the tangent, if we divide everything by sine of theta, which is positive in this picture, we get this image. And because of these inequalities, if we take reciprocals, we will change the direction of the sign so that sine of theta over theta is greater than or equal to that, which is greater than or equal to this. Then if I clean up and simplify, the first thing is a 1, the middle term is sine theta over theta, and the final thing is cosine theta. So we can interpret, which is a little bit of algebra, the picture drawn at the bottom as telling us that sine of theta over theta is always less than or equal to 1, and at the same time, sine of theta over theta is greater than or equal to cosine of theta. So what does this tell me? If I know this inequality, that sine of theta over theta is squeezed between 1 and cosine of theta, then when I take the limit as theta goes to 0, sine of theta over theta will be squeezed between 1 and the limit of cosine. But the limit of cosine is 1, so sine of theta over theta is squeezed between 1 and 1. So the limit as x goes to 0 of sine of x over x is equal to 1. Earlier in our class, we discovered this using a calculator. We got estimates close to 1. This is a proof that, in fact, this limit is equal to 1. Another limit we will need in this class is the limit of 1 minus cosine x over x as x goes to 0. Notice that simply plugging in x equals 0 does no good in this case. But we can get at this limit by using a little bit of algebra and a trig identity. If we multiply the numerators and denominators of this fraction, 1 minus cosine x over x, by the so-called conjugate of the numerator, by 1 plus cosine of x, then 1 minus cosine x over x is equal to this expression, and if I multiply through the numerators, I get 1 minus cosine squared x as the numerator. However, by the Pythagorean theorem of trig, 1 minus cosine squared x is sine squared x, so now I have this expression, and now I can break it up. The sine squared on top becomes sine x in one fraction and sine x in another. We factor the denominator also, and I've written now 1 minus cosine x over x is equal to this product. Now the first fraction in this product, sine x over x, we've seen before. We know that the limit as x goes to 0 of sine x over x is 1. And the second expression, sine x over 1 plus cosine x, we can just plug in. If we just use basic properties of limits and plug in, we get that that limit is 0 over 1 plus 1, which is 0. So this expression we're looking at, that we've broken into two pieces, will be the limit of the two pieces. And the limit of the two pieces are 1 times 0, which is 0. In other words, 1 minus cosine x over x goes to 0 when x goes to 0. The two identities that we have come up with, the two equations, are the limit as x goes to 0 of sine x over x is 1, while the limit as x goes to 0 of 1 minus cosine x over x is 0.